Hey everyone, and welcome back. So before we begin here today, please make sure you like and subscribe because it really does help out our channel tremendously. And it also helps us reach others in need of assistance with these topics. So what we're going to be talking about today or going over today is trigonometry and calculating angles and right triangles using the trig functions of sine, cosine, and tangent, and the inverse of those trig functions in order to find out what this particular angle theta really is, what its value actually is. So what you would normally do for a right triangle problem like this is that you would just use one of these trig functions of sine, cosine, and tangent because it's much faster to do so. But in this one, we're going to be doing sine, cosine, and the tangent trig functions just to show you that it doesn't matter which one you end up using. They should all give you the correct angle value in the end. But this is just to show and give practice on how to use all three of these. So when you're using sine, cosine, and tangent, it is very helpful to remember the acronym of SOH-CAH-TOA. So SOH-CAH-TOA. So these would correspond to sine, cosine, and tangent. So the sine of your angle is going to be the opposite side over the hypotenuse. The cosine of the angle is going to be the adjacent over the hypotenuse. And then finally, the tangent of your angle is going to be the opposite over adjacent, which matches up with SOH-CAH-TOA up here. Now, since we are using all three trig functions here to solve for this angle, we need to know all three sides of the triangle, which there are only two given here at the start. So looking at this triangle, since our angle is down here in this corner, the side that is attached to the angle theta, which is one of the two legs, this would be the adjacent side. The 4 over here is opposite the angle. The angle is not measuring off of it at all. So this would be your opposite side. Then, of course, the longest slanted one is the hypotenuse side. So using the Pythagorean theorem, we can find that adjacent side, which the Pythagorean theorem is just your hypotenuse squared equal to the adjacent squared plus the opposite squared. So we can just rearrange this in terms of the adjacent side, which the adjacent side would be the square root of the hypotenuse squared minus your opposite side squared. So if we plug into this equation, our hypotenuse is 7 squared minus the opposite side of 4 squared. Once we calculate that out, take the square root, and our adjacent side pops out to be 5.74. So now with all three sides of the triangle known, we can actually start solving for the sine of the angle, cosine of the angle, and tangent of the angle, or solve for the angle using those three trig functions of sine, cosine, and tangent. Keep in mind the previous videos, we just solved for sine of theta, cosine of theta, and tangent of theta. This particular video and the previous one, this is part 2, the part 1, where we actually solve for the value of this angle. So let's use sine first. So the sine of our angle theta is equal to the opposite side over the hypotenuse. So that would be equal to 4 over 7. So this 4 over 7 in decimal form is 0.571. So what I have here is the sine of my angle is equal to 0.571. Now, in order to find out what this angle actually is, we have to use the inverse of this trig function. So we have to go sine, let me rewrite that, it's a little bit messy. So we have to go sine inverse of this value of 0.571. Keep in mind, when you see trig functions with this inverse symbol, it is not the same as like when you're in algebra or previous classes where you have x to the minus 1 would equal 1 over x. This sine inverse here is not saying that this is equal to 1 over sine. That is incorrect. It is a totally different system and a totally different trig function. It is not a simple algebraic variable. It is an actual function. So most calculators out there will have the ability to do sine, cosine, and tangent. And if they have the ability to do that, they will have the ability to do sine inverse, cosine inverse, and tangent inverse trig functions. most of the buttons on there on your calculator will show sine, cosine, or tangent. And then you have to either press them twice or do some kind of operations that you will see sine inverse, cosine inverse, and tangent inverse. That's what you want to utilize to solve this. So when you take the sine inverse of this 0.571, this angle pops out to be 34.8 degrees. So if you get something, if you're plugging in the correct sine inverse of 0.571, and you get something other than 34.8 as your answer, your calculator or whatever you're using might be in radians mode. Now, we've done a previous video on the difference between radians and degrees, and if you're not sure what a radian is, please check out those couple videos that we have on the channel here discussing the difference between degrees and radians. So you want to make sure that your calculator or whatever you're using is in degree mode in order to get this answer of 34.8 if you're following along. Oh, alrighty, let's move on here. So next we're going to do the cosine of the angle, which is the adjacent over the hypotenuse, which our adjacent for our angle is 5.74 and our hypotenuse is 7. So in decimal form, that equals 0.82. So what I have here is the cosine of my angle theta is equal to 0.82. And just like with the sine function, in order to determine what this angle actually is, we have to use cosine inverse function of 0.82. And this gives us an angle of 34.9 degrees, which is very, very close to 34.8. The only reason that it is off by that decimal point is because of rounding. That's the only difference. Rounding plays a very big role in any type of calculation. As long as you're really close, it's giving you the same angle function here. Now, it just depends on how much you want to round, how close you want to round, and just make sure that you're rounding the same way all the way through the problem if you want to get precise answers, or as precise as you can be. But in my book, 34.8 degrees and 34.9 degrees, that's the same answer. So lastly, we will have the tangent of our angle, which is equal to the opposite over the adjacent, which in our particular triangle's case is 4 over 5.74. In decimal form, this is 0.697. So the tangent of our angle theta will come out to be 0.697. So let's find out what actual angle will give this value when you're taking the tangent of it. So we would have to do tangent inverse of 0.697, which our angle comes out to be, well, you probably guessed it, 34.8 degrees. So this problem just goes to show you that it doesn't matter which trig function you use, sine, cosine, or tangent, the angle should be the same or extremely close due to rounding issues. But overall, this is why most of the times when you're looking for an unknown angle value, you just use one of these, not all three, because they will all give you the same answer in the end. So we've done a previous problem, which is part 1 to this, where we did a different triangle going through this. If you want more examples of that, just go back and check that part 1 of this video series. And the other next couple of videos we're going to be putting out, we're going to be solving a lot of right triangles just using one of the trig functions. And we'll be talking about which one would actually be the fastest to use if you're missing information, such as this problem where we were missing the adjacent side. So I hope this video was helpful. And as I mentioned earlier, there are other videos on our channel going over this particular topic. So please check them out on our channel. Also, if you haven't done so already, please leave this video a like, leave a positive comment, and please subscribe to the channel because it really does help us out and it's helping us grow. Thank you for watching, and I hope you have a fantastic day.